We talked about this, right? So we talked, and you know from high school, you know averages, you know how to calculate an average. So this is basically what you do. You calculate central tendency and variability of your data, and you basically you mean to characterize and describe it in order to come to the next level of statistics, where you basically can draw inferences from your data. So you basically you gain insights into your data, in dynamics in your data over time, and you use and utilize your data to make estimates of whatever dynamic or characteristic of your sample to a larger population. And this is basically where we come back to the definitions we discussed already on Monday. We're defining population according to what we are, what population we're interested in. So it is a defined group that can be any size. So it's really up to you how you want to define your population. It can be all students at YU. It can be all people living in New York. It can be citizens of the US. It can be global population. You define it. It could be any size. However, what's important, the sample that you study is a subset of your population, which you use to characterize in what shape or form and analyze in whatever shape or form to basically draw inferences to your population of interest. So it's a portion of your population. And these sample results are basically, so you need, when you think about it, like a population, it's hard to capture dynamics in a population. So you make it feasible by studying samples that you basically can study. And this is what we will be doing the entire semester long. So in essence, you want to characterize your sample population by quantifying variables. And variables can have different shapes or forms. They can be discrete and they can be continuous. When they're discrete, they are very restricted in what values they can actually take on for each individual entry. So it's a predefined category, it's a predefined definition of what value it can take on. You define nominal and ordinal variables, where nominal variables, as the name implies, has a name. So that could be, for example, biological sex, is male or female. Hispanic ethnicity or no Hispanic ethnicity, common in my analysis. It can be racial categories, it can be African Americans versus white Caucasians versus Asians. Nominal variables that have names. And this is in contrast to ordinal variables, where you have some order or ranking amongst your values. So this could be student performance. Hello? I'm trying. Yeah. So basically, ordinal has some form of order or ranking within that variable, within the possible values that variable can take on. There can be performance in class, who are the high performers, who are the less high performers. This can be ranking of preferences, who likes, I don't know. Can be age groups, also typically ordinal. Everything that is ranking and order. And we will go through some examples. And then as the second larger group, you have continuous variables. So these variables typically can take on any value, which essentially can be classical parameters: age, weight, height, everything that can take different values within a certain predefined range. And there you distinguish between interval and ratio variables. Interval, as per definition, are equally spaced numbers that essentially can take on any value. Slightly in contrast to ratio variables, they can also take on any value, are equally spaced, but do have a meaningful zero. And I'm seeing the skeptical looks. What does that mean? And I'm going a little bit forward to my favorite example in that regard. So to be honest, ratio variables is nothing. So there are textbooks that will never talk about ratio variables. So this is something very specific to this textbook, but the definition essentially is clearly outlined here. So let's think of cookies. So the nominal variable to characterize a cookie jar is essentially what is the name of the cookies in that cookie jar? Is it oatmeal raisin? Is it chocolate chip? Whatsoever, whatever cookie you want to think of. The ordinal variable to characterize that cookie jar and that cookie would be how much, is it your favorite cookie or is it your least favorite cookie? On a scale from 1 to 10, rank how much you like that cookie, right? So it's a ranking. Thirdly, would be, are these warmed up cookies or these cookies that just came out of the freezer? I don't know whether it's common to freeze cookies, but it's generally its temperature would be typically equally spaced number, which can take on any value. And ratio, and this is where the meaningful zero finds its explanation. Ratio is the meaningful zero of how many cookies are left would be 0. There are no more cookies. You can't go negative, so it has to be a positive value, and the 0 is meaningful because it's null. Does that explain it? Any questions? Yes? Interval is equally spaced and can take on any value and can be either positive or negative. And the most important characteristic is 0 is just some number. Whereas when you have a meaningful 0, like in ratio, it's basically disregarding the entire entry. So if you have a 0 entry, it's 0. There's no cookies. Does it make sense?
Yeah.
I know it's a little bit of a tough, but you will get to that distinction because we will be talking about time. Time also doesn't have a 0, also can't be negative logically. So this is a typical ratio variable. Whereas an interval variable would be temperature. If you measure the temperature of 100 people, this is a typical interval variable. It is, bluntly spoken, it's important because you kind of have to think about expected values, expected ranges. But it's then less important. You will never be asked to define interval or independent or ratio. It doesn't really change the way you would approach them analytically. And this is why I made the point before. It's a distinction that many textbooks don't do because it doesn't really have much ramifications whether the interval or ratio. So this is just a good example to essentially understand the different variable types. We will now look into data collection, how data can be collected. And for that, to illustrate data collection and data organization, and also a little bit of analysis of this data, we're gonna look at a test that is being used in clinical psychology, and it's called the Stroop test. In the Stroop test, you're calculating reaction time. And this reaction time is collected in 2 different settings. It's essentially the time to say the color compared to the time to say the word. So it sounds confusing, it's a little confusing, but we will do. May I have a volunteer? Yeah, great, thank you. Okay, I show you 4 words. Can you please read this to me?
White, red, green, red.
Very good. That was a pretty good time. So now in the following, I'm showing you 4 words. Can you please tell me the color of the font?
Green, green, red, purple.
Very good. Thank you. So it's a tricky test, right? It's really tricky. And if you sit down and you're super concentrated, it takes you a longer time to give you congruent, which is this. Thank you very much for volunteering. So this is congruent. This is incongruent. So incongruent.
The first time was congruent.
Congruent is where color of the font and the word corresponds or is congruent, and incongruent. There is a different definition. So the reason why I'm saying congruent, incongruent, I kind of want to move on to the Excel spreadsheet. So there's an Excel spreadsheet in the module which basically labels it as congruent and incongruent. So I didn't use this word. I would have given a different label. I downloaded this from OpenIntro, so they called it congruent and incongruent. So we have here data of 24 individuals that have done exactly that exercise. One time congruent, one time incongruent. And you have 24 different numbers. Already with the naked eye, when you look at this, you see that congruent is kind of a shorter reaction time, a shorter time to process and to actually give you a response, right? With incongruent, it's substantially longer, for good reason. So you have 24 entries. You have both of the both conditions were fulfilled by each participant. And you basically have here what kind of variable? It's time. Meaningful zero. And no cookies left. It's a ratio variable. And so we have time for congruent and we have time for incongruent. And we have here a subject ID, which is a random ID. That would be a nominal variable. You can also label it an ordinal variable because it's in a ranking. It depends from which angle you're looking at it, because if you study patients in a chronological order, and the chronological order is actually an ordinal variable. In reference to the times, it's a random number. It could be names. Yes.
How do you know that it was a ratio, not a total?
Well, because it has meaningful zero and it can't be negative.
But the other one isn't negative either.
No, both are ratios. Both are ratios. Did I say one was into it? No, they're both ratios. Independent of how often you do that experiment, this just is a repetition of the same experiment, so that the outcome measure is the same variable. They're both ratio. If I misspoke, then apologies. They are both ratios. So this is essentially the data, how you would collect it if you would do this as an experiment, as a study for your thesis or your study or your paper whatsoever. So now essentially you can quantify, and this is where descriptive statistics comes into play. You can quantify and characterize your sample population outcome measure of time by just calculating an average. You remember from high school averages, you sum up every individual entry and you divide it by the number of entries, right? Alternatively, you use the average function in Excel, which is basically equal sign average, and then you define that range of data that you're interested in as starting cell B2 colon, which indicates it is an actual array, so an actual array of data, colon final cell. And this will define B2 to B25 for congruent. And you can do the same exercise for incongruent. Yeah? So that's an average. And when you compare those two averages, you essentially see already that congruent was shorter for the entire sample population as compared to incongruent, which was greater. What does that mean? Incongruent is more difficult, it takes more time. Based on that sample, likely it will be the same for my population. And this is where you're trying to extrapolate your insights from your sample population to your overall population. Yes.
Sorry, just to confirm, these numbers, like congruent of the times that it takes to first read the congruent letters, like we're still on the Stroop test.
Yes.
Okay.
So these are results from the Stroop test, which I have here downloaded from that website.
Okay. Cool.
So that's an actual experiment. It's like I think this from some university they published it there.
Yeah.
So now this is what you can do to basically answer your research question. And the research question could be, does it take longer to state the font of the color versus reading the words in a Stroop test? So, what's the Stroop test certificate? We talked about that. Nominal, ordinal, interval, ratio, like interval, but it's meaningful 0. Talked about that. Talked about the cookies. And now it's getting a little tougher. So we talked about discrete and continuous. We talked about nominal, ordinal, interval, and ratio. A nominal is always discrete and never continuous. It can't be continuous. It can't be made continuous. It's impossible to make it continuous in any shape or form. If you have name, you can't, if you have different names of participants or different subject IDs, for the subject IDs, you hypothetically, you could, if it follows a certain order, that's where it becomes an ordinal variable. You could hypothetically define it as an ordinal variable with a specific research question. But in principle, nominal variables are always discrete, never continuous. Ordinal are always discrete, never continuous. There are ways how you can kind of force them into a continuous shape. I advise against it. In some rare occasion, it is being done, and in some rare occasion, it must be done even. An ordinal variable would be, for example, age groups. So one way that you may possibly even have learned at some point in high school is you can take certain ranges. If you have ranges, you can define a midpoint in that range, and you can kind of transform this into a semi-continuous shape.
That's ordinal or interval?
It's ordinal now.
Why would age group be ordinal if?
Well, it's
It's
zero.
a range of ages.
It's a range of ages, but it becomes a nominal or discrete variable, but it follows an order. So it's 0 to 10, 10 to 20, 0 to 10, 11 to 20, 21 to 30. So it has an order.
So what would an interval be in relation to the age group?
An interval in relation to age group, well, you can kind of transform it by saying, okay, so I have this age group, and I assign for each participant in that age group, I assign 5 as a midpoint of 0 to 10. I would advise against it, but you could hypothetically, let's say you have a situation where you have missing values, and you only have the group that individual is in. And this is that rare occasion where this is legitimate to do that, that you kind of take the age group and you kind of define what is in between, and you take that midpoint and you fill that missing value with that group that individual is in. You can let the imagination flow. It is possible to fill missing values that way, but I advise against it. It's generally not good practice to do that.
I was saying like more in terms of how you define the age groups as ordinal. What would like a set of values be defined as interval? Like would 0 to 10 be an interval?
0 to 10, no, well, it's an interval of data, yes. It's an interval, it's a range, right? That is true. But the variable resulting from that becomes a group, a category,
Okay.
to which that individual is assigned to. So if you have an individual and you have an entry of somebody who is 8 years old, he's going to be in the group 0 to 10. That's where it becomes categorically. But hypothetically, if you know of the individual only, he's in that age group between 0 to 10, and you say, okay, I give everybody in that age group a midpoint, you're not even making the continuous variable in any shape or form. You're just assigning a value that kind of corresponds with that age range. So now intervals are sometimes discrete. So we know they're continuous, right? This is a continuous variable, but sometimes they can be discrete. And that case is, for example, is a good example is like if you have very small ranges of age, for example. If you study a fetus, or if you study fetuses with an ultrasound, with sonography, and you have like 1 to 5 months of diagnosis, then this becomes a categorical variable, month 1, month 2, month 3, month 4, month 5. So this is how you can think of it. Sometimes it's also a discrete variable. With ratios, very seldom a discrete variable, but almost always a continuous variable. So just, so this slide, yes, please. Yeah, that's a range, but it's not an interval variable, right?
For the strict demonstration,
That was ratio.
that was the ratio we were comparing under, but that was the ratio because we were comparing those two different.
No, because it has a meaningful zero.
That's what made it.
That's what made it ratio. With the cookies, right? Think of the cookies. Interval variable is temperature of the cookies. Can be negative, can be positive. Zero is just some number on that range of possible values for this variable. Whereas the ratio variable has meaning for zero and it can't be negative because if you have no cookies left, you have no cookies left, right? So you can't have negative cookies, except for if you take a cookie loan. But yeah, so it's not possible, right? It's zero is meaningful. Does that answer the question?
Yeah.
Yeah.
I think I'm still having trouble with the difference between ordinal and integral.
Can you please repeat?
I think I'm still having some trouble with the difference between ordinal and integral.
Okay. And since sometimes interval can be a discrete number, it's understandable that they have issues distinguishing because sometimes you can't. So an ordinal number is a categorical variable when individual is being assigned to a certain category, right? If that individual is in a certain age group, then this individual is in that age group. If you have the next individual, you have a predefined category for that individual too. So you have somebody who is 8 years old is in the age group 0 to 10. You have somebody who is 13 is in the age group 11 to 20. If you look now on the other way around and you go for interval and you study, I don't know, you only study a class or you study a school in which you have students between 11 to 14, for example, then this interval variable of how old is the student will become a category rather than a number. So it can be treated as a categorical variable. Does it make sense? Because you, in essence, where it has ramifications is how you would deal with this analytically. Because if you have a category, the way you would characterize your category is by counting how many individuals are in that category. Whereas with an interval, if you have an interval number and you have an age range from 10 to 90, you would basically approach this by calculating an average and the standard deviation. So it's a different analytical approach. This is why the distinction is important, because it really depends on your research question, and it depends on how you want to deal with this data overall. Yeah? Yes.
How is age something that can be integral if you can't have a negative age?
Age is a ratio.
So that age would not be classified.
Well, it depends on your definition, right? Yeah, good point, actually. Yeah, kind of moving in on an interesting topic. Yeah, age generally, if you define a population and you just say, okay, so age is a variable that can take on any value, and I don't restrict this to a certain age range, it will become an interval. Yeah. A lot of these definitions are really dependent on the research question that you're asking it, and these are just general rules of thumb, right? And I'm just teaching you those definitions. If you would if you would have a research question that you're interested in any age, yes, you would basically look at this as an interval variable. Analytically, this will not have any ramifications whether you treat it as an interval or a ratio variable. So good question though, really good question. Any other questions? It's as a concept, it's quite central because you learn to think about variables and then you learn to think about the difference of those between those variables. Okay, if no question, let's move on. So that's the next concept that is super important. So we have dependent variable, we have independent variable, and we have confounding variables. A dependent variable is a variable that you measure. Stroop test, reaction time. An independent variable is a variable that you manipulate or in some form or shape categorize. Examples with the Stroop test, let's stick with the Stroop test. The dependent variable would be the time it took the respondent to give the correct response. The independent variable would be, was the words the individual looked at congruent or incongruent? The categories, that makes the difference. If you think of a randomized controlled study, did the patient have the blood pressure medication or did he not have the medication? Two categories. So that's the independent variable. And that's a very important concept. So please memorize that one because we will repeatedly have to use that. A confounding variable is a variable that you try to either use for the diagnosis. In the Stroop test, for example, a confounder could be a stroke that you mean to diagnose with exactly that test, or a psychological condition that you mean to diagnose with that test, because that will cause the respondent to take longer to respond. And the difference between congruent and incongruent will be longer. I feel bad, I'm always standing. Okay, so dependent, independent, confounder. That's the triad. So you basically have an outcome measure, which is the dependent variable. You have as the determining variable, you have the independent variable, affects the outcome dependent variable. In the middle, and you have to think of that as a third variable that is somewhere in that pathway and affects this pathway. And you mean to essentially in group comparisons in a randomized controlled setting where you try to compare blood pressure, no blood pressure medication, you essentially mean to account for that. You mean to kind of take this out of that pathway. And there are analytic tools how you can do that. And that's, yeah, that fills weeks of conversation, how to deal with these confounding variables. And that's extremely, extremely difficult in analysis. Because as you can, so let's stick with the blood pressure example. So blood pressure example, you mean to give a blood pressure medication to lower blood pressure. And you study this in a sample of your population. You measure blood pressure when the patient enters the study, and you measure it 6 months later after taking the medication. In a placebo-controlled study, that patient doesn't know whether he actually really takes medication or he just eats a mint. So he doesn't know that. And over 6 months, after 6 months, you compare the blood pressure and you see low in the blood pressure medication, still high in the control group. So now the independent variable is the group assignment. The dependent variable is the blood pressure difference from month 0 to month 6. Or the blood pressure at month 6, depending what analytical tool you use. Confounder is, what could be a confounder? The cause of blood pressure or high blood pressure was essentially not to be affected with the medication. Or you studied a group of patients that had, that never had high blood pressure. You did a wrong sampling, you made a sampling error. So there are various reasons why these confounders become operative in your analysis. And these confounders are important to understand and to determine, to find out what actually caused your lack of effect or you amplify the effect in whatever direction the confounder affected your effect. Does that make sense? Any questions? No? This is a very important concept. So this really memorize very well. Okay, dependent, the measure, independent, the category, confounder, somewhere in between this pathway, in some shape or form, affecting that pathway between exposure and outcome. Then when you measure your dependent variable, it's important that you have a measurement tool that is reliable and valid. Reliability means that you measure the height of that student, of that patient, of that participant on the first day, and you measure it again on the second day, and it's still the same height, because there's no way that height changed. So that is a reliable measure, which is still the same if you repeatedly do the same measure, in the absence of active changes that have a different reason than the measurement tool. A valid measure is one that actually measures what it's intended to measure. That means if you want to measure the height, it's not enough to just look like and estimate it. You need to actually have a measuring tape, or you need to have some installation that measures it. And you need to be confident about the accuracy of that measurement. And so the measuring tape is actually a good example, because that is, bless you, that's a considerably valid measure and usually rarely inaccurate, rarely, still possible. So other methods are not reliable, other measures are not valid. Best example coming from my world, so I come studying a world of kidney disease patients that cannot excrete fluid anymore. So they actually have increases of fluid volume, which would be really useful to be able to measure very accurately. It fills books how difficult it is to measure this accurately, because it's virtually impossible. You cannot look at the patient and say like, okay, so you probably have like 5 liters of fluid volume overload that needs to be removed with a very technological process named dialysis. So this is very complicated. And you also don't know what's physiologically actually for this patient. You don't know what would be a normal healthy weight, fluid weight for that individual, which fills the second set of books. So it's very complicated to have reliable and valid measures. A good variable is both reliable and valid. That goes without saying. But unfortunately, there are not many reliable and valid measures. So it's all about accuracy, and it's about testing them. It's about seeing how do they associate with the actual outcome. And this is where the independent variable then would be the measure. But let's focus on the measure as the dependent variable for the sake of argument and for this class. So as an example, Nolan and Heinzen here give the Rorschach ink blot test. Does anybody know that test by any chance? Yep. So I am not a psychologist. I cannot comment much on this test, but it is used for various use cases. One of them, for example, is the diagnosis of personality disorders in teenagers, then for some pathological reasons in later age. Essentially, what it looks like is like this. No. It is essentially a rather abstract form that the respondent is asked to characterize and interpret. So now, as you can imagine, if there's an ongoing psychological process, the interpretation may change, and this takes already kind of reliability a little bit on the chopping board. And then with validity, I'm not sure what can be diagnosed by an interpretation of this figure. Again, I'm not a psychologist and I will not comment on the usefulness. It is for me as a data guy and a numbers guy very hard to see how this can be used as a metric. But again, I'm not qualified to say anything about it. So, but others have also questions the validity and the reliability of the test. So I seem to be not alone. And so essentially, this is an example of a test where reliability and validity has been debated. So just to make the argument that not every test, not every measure is really accurate, neither reliable nor valid. Any questions to any of this so far? No? Good. Hypothesis testing. No, let's go. Let's do something. Yeah, no, let's stick with hypothesis testing. Okay, hypothesis testing. That is the process of drawing conclusions about whether a relation between variables is supported or not supported by the evidence. So essentially, a hypothesis is based and formed by a research question. You have a research question, you will base your hypothesis based on that research question, and you will phrase it in a way and shape and form that you will operationalize variables to help you answer and either accept or reject the hypothesis you pose. Usually this is done in the form of a null hypothesis and an alternative hypothesis. The null hypothesis is the hypothesis where you say, I'm giving this group a blood pressure medication, this group a mint. I hypothesize under my null hypothesis that there will be, after 6 months, no difference between these two groups. And I know this sounds a little bizarre because essentially you would think it's the other way around, but basically your null hypothesis is your primary hypothesis, which is a resultant of your research question. And you assume that there's no difference. You hypothesize there's no difference. And statistics will essentially give you statistical tools in your hand, which you will use to challenge your null hypothesis and to determine whether the probability of this null hypothesis is actually so small that you're willing to reject the null hypothesis with sufficient certainty and accept the alternative hypothesis that there's a difference between these two groups. I know this sounds complicated and we will talk about this more, but for now, just basically remember that hypothesis testing is used to draw conclusions where you basically test the relationship between two variables, dependent and independent variable, additionally accounting for that nasty third variable that confounds your insights. So that's the idea. To do that, you need to assess your variables and you need to define your variable. And this is the operationalization. And that's a little bit of a tongue breaker, but it's basically particularly for me as a non-native. But operationalization means that you have data of a sample population that basically you are utilizing and defining to define a dependent variable and independent variable and confounders to answer the research question you're interested in. So you basically use this to develop a framework between these three different variables, dependent, independent, confounders, to basically test your hypothesis. This is the operational definition and the operationalization of variables. So what does this mean? So if you are interested to find out if pet owners are happier, you have a group of individuals, that's your sample. You get whatever measure you are using, you define the level of happiness. So believe it or not, there are happiness scales. There are also depression scales. Psychology is very, very innovative when it comes to these scales. And so a happiness scale, you ask every individual to rate the happiness on the scale from 0 to 100. And you take this and it becomes a ratio variable, right? So this variable, essentially you will then use as a dependent variable. And then you need to define an independent variable to answer the research questions. Are pet owners happier? And your independent variable is pet ownership. Easy, right? It's not always that easy, but this is the simplest case. And you will, and this is why this example is actually so good, because you will, on those quizzes, you will get a text of somebody describing you a certain research interest, and you will be asked to define these variables. And it's also taking a step back again. You're writing your thesis, you're writing paper, whatever you do essentially in research, you will have a certain research question, and you will need to figure out how to answer this research question most efficiently and effectively. Okay, level of cigarette smoking. Under the assumption that people who don't have enough willpower, or the assumption could be cigarette smokers don't have any willpower. So you basically, you have the dependent variable is how many packs of cigarette is this individual smoking, or is the individual smoking at all? And the independent variable would be amount of willpower. How caring people who use social media a lot are do not care about people. This is an example that Nolan and Heinzen have a couple of times. So dependent variable, how caring people are, and social media use. Uses social media frequently, not as often, or very often, or not at all. So this is operationalization of variables. So operationalization needs then, and this is where I go back now to the Stroop data. I'm always trying to find a good gap and window to not make it too confusing and have a good flow. And I think this is.
Did we discuss conceptual variable?
The operationalization?
No, just. I'm just going back to this slide.
This one? This one? Do you have questions to that? Okay, let's go back to this.
Meaning just the conceptual variable versus the operational.
So you have, yeah. So you have a conceptual variable that is your independent variable in essence. So the research question will basically give you the concept. From that concept, you move then to define variables that will allow you to build that framework of dependent, independent, and confounding variable. So this is where the concept moves into operationalization. And operationalization is nothing else but defining the outcome measure and defining those categories which you are interested in to find the effect on. Yep. And one way to do that is, so you can do various things, right? So we have with the Stroop test, and this is where I'm going back to the Stroop test, you can, for example, you can do various things. That's actually not that good of a flow. I should have done that earlier. So you have, for example, with congruent and incongruent, you have an independent variable. These are the two categories you're in. And you can quantify now your outcome measure here, either as a continuous variable, or you can also discretize it. And I didn't talk about this before. So you can discretize it by transforming it in an ordinal variable, where you basically, and this is the same variable, but now note that the subject IDs are now not in order anymore, because now they're basically sorted and ranked according to the responding time. And we have done that last time by ordering. So you can order your data. Oops, it's to go. So you can order your data easily with the order function. So you go and sort. You select subject ID to D25 or T26. A2 to D26. You go and sort. Second tab. The second spreadsheet. It says transformation. You have the spreadsheet?
No. It's okay, I'll come to you.
No, but did you download the same Excel spreadsheet? Does nobody have a second spreadsheet?
I don't have this spreadsheet specifically.
On Canvas in the module, you should have a spreadsheet. Found it? Found it?
Yeah.
Okay, great. Okay, so you download it from Canvas. Everything is always in the modules, and you will have there two different spreadsheets or worksheets in the spreadsheet. So you have one which is Stroop data, and the second one is transformation. And I just quickly want to talk about this, and this shouldn't take us too long. So it's just you have here subject ID congruent only. You have you can, by selecting this entire part from A2 to D26, you can sort it now freely. So you can sort it. If you click on sort of the selected area, you can sort it by column, which can, if you do subject ID, it will basically resort it. It will resort it as according to subject ID. Yes.
When I opened it on my laptop, for some reason it didn't open in Excel.
It opened it in numbers. If you click on the file and you make a right click on it, it will tell you open with.
Wait while I go back to Canvas.
No, you just download it in the class.
This is what I'm looking at right now.
Yeah, this is numbers. Just close this. We don't need this. If you download it in your folder, you remember how we did the class folder last class?
Yeah.
Just download it in the class folder and then click on the file and make a right click on it and say open with. Or we can do the exercise. You want to do it? So you go on Canvas, you go on Stroop data, which is here. You open this up in Canvas, it will download it. It will end up in your download folder. If you can't find it, you find it in your download folder. And now you drag it to desktop, to your STAT1021 folder, which can be here. You drag it into module 2, or class 2. And yeah, then you just go into the folder and you make a right click on the file and you say open with. And if you don't have Excel here as an option, you go on other, and that will automatically open your application folder. Yeah.
Yeah.
And there you find Microsoft Excel. You select it once and you select then always open with. Then it will never open it again in numbers. I don't wanna talk bad about numbers. I'm a big Apple fan, but it's like I don't like to work in it. I prefer Excel. So I would change it to always open with. But it's up to you. It's like if you want to do in numbers, I can equally look at things in numbers. So always open with will basically avoid this from happening in the future. So now you have two worksheets in your spreadsheet. The first one is the file that we looked at with the averages. The second one is transformation. And I just want to quickly talk about this because the outcome measures we talked about continuous variables and discrete variables. Where discrete variables are basically categories and continuous variables are numbers that can take on any value. So congruent with it determined before as a continuous variable, more specifically a ratio variable. It can basically be assigned if you order, and this is what the sort function comes into play. You sort your data according to the congruent time. It will basically allow for you to rank because you have the order there, right? You just need to make a list from 1 to 24. So you can order it. And this additional variable is now an ordinal variable. Right? Makes sense. And now you can further discretize it. And this is the discretization. Today we're talking a lot about, a lot of tongue breakers today. So it's the discretization, it's the discretization of continuous variables. And you're basically assigning continuous variables, entries with continuous variables to respective categories. So if you say, okay, everybody who took longer than 15 seconds is now being assigned a 1. That is one way how you would do that. Because now this variable is a categorical variable, right? Simple. This is the discretization. And the formula how I did that, and I encourage you to look at this formula, because this is a formula that will be very helpful for you moving forward when you ever deal with data. So this is a so-called if function. If will allow for you to define a criterion, which is this part here. And this criterion is essentially a logical test. So B3 is this cell. If this cell is smaller than F2, which is this, then, and this is after the comma, this is the value if true, give it a 1. Comma, and then after the comma, the last part is value if false, then give it a 0. What it will do, and that's the beauty of it, it will automatically allow for you to populate the entire row down, and it will assign these values to your data, to every individual entry. Why am I telling you this? Because this will be very useful to you, and I strongly encourage you to really kind of try to, yes.
Why is there the dollar sign?
Yes, good question. Thank you for asking it. Because if I take the dollar signs off, that's actually where I wanted to go next. Because if I only say F2 and I only refer to that criterion, you remember last time when we parallel shifted this equation? So if I change this and I'm propagating this formula down, they will all change to 0. Why? Because you want to compare. Let's look at this cell, for example. It shifted down the actual value it was comparing to our reference value. But the problem is it also shifted the reference value, the reference cell down. And with dollar signs, you're locking the cell.
But if you were subtracting it, you wouldn't have to lock this out.
You could do that, yeah.
But if you don't put the dollar sign, it wouldn't lock and it wouldn't change.
Well, it does still, because you essentially want to refer to one cell, because the beauty, so if you lock it, let's just lock it for a second. So you can lock with $F, you're locking the column. With $2, you're locking the cell, right? So it will always refer to the same cell, and it will not shift back and forth. So if I do this now, it basically is back to taking the correct reference value. So the beauty of using this format and to have the criterion explicitly defined somewhere is because if I'm changing this criterion here, it will also change all entries. And that's the beauty of it. And I don't want to make a programming class out of it, but it is part of it that you know how to use these tools. And I think this is, hopefully one day you will be very thankful to me. And the feedback I've gotten from your colleagues that have passed my class, it holds true. So if you change this criterion here, it will change the entire data series. This is what in programming jargon we're referring to as soft coding. Hard coding would be to go here, delete this whole thing, and say 15 here. That's hard coding. Still gives you the same result. Was 15, but it's hard coding. So now imagine, and now if you write a paper, if you write a thesis, the lines of code you would use in R, I'd estimate somewhere around 3,000 to 4,000 lines of code. If you need to change a criterion you implemented on line 2 150 times, this will be a lot of time wasted for something that can be avoided by soft coding it. This is why I think this is important. Okay. All right, take it in as what it is. I hopefully at a later point it's going to become clearer why it's really useful. Trust me, just trust me for now. Okay, so we are going back to defining this as $F, $2. And the discretization essentially is here very nicely shown, because if I take this as a continuous variable, I'm calculating a mean and the standard deviation, and I characterize it as a continuous variable. If I take it as a discrete variable, I will do a so-called frequency table. And this is what I will have the pleasure to teach you next week, how to do frequency tables, where you basically sum the number of entries. And so there are ways and functions how to do that. We're going to talk about this next week. Good. So this was this part. Any questions to this, except for the 150 questions that you probably have? Yes.
How do I get, if I in the formula, how do I get it to go down to the whole series?
Good question. So you basically you finalize you finalize your, okay, so let's do it new. Let's do if F, now B3 is smaller than $F, $2, which is our criterion, right? Comma, concludes the logical test. And now we have the yes if it's true definition. So it's faster than 11. So that makes it fast. So we're defining this now as quotation mark fast. With a comma, we're concluding that, and we're going to else, and we're saying slow. So now we have this for the first entry, right? And now we hover over the cell until we get to the right lower corner, where the cursor changes to this full solid black cross. And this is where we're double clicking. And that will complete the entire data series. Exactly. So on the, yeah, worked. Okay, then you may not have the correct number, the no correct formula. So if B3 is smaller than $F2, $F, $2, comma, fast or 1, comma, 0 or slow. Whatever you prefer. Whether you want this as a nominal or ordinal. Yeah. So just go back to the original formula, because the original formula was correct. If you go on the right lower corner, you can propagate it all the way down. Then the formula automatically expands all the way down. Yeah? Okay. All right. Back to time is flying. Time is flying when you're having fun. Not sure that's true for you, but I have fun. Okay, good. All right, so correlational studies. So, okay, we talked about hypothesis testing. We talked about the operationalization. So there are different ways how to analyze data. So now we did hypothesis testing. You're comparing two groups. You defined your groups, pet owner versus non-pet owner. And this is one way to look at this. So you're comparing differences between the groups. Another way of looking at data is by doing correlational studies. And this is what we're going to do in lecture 16 and 17, correlation, and now 15 and 16. 15 is correlation, 16 is regression. where we're basically trying to quantify associations and correlations. So an association here is basically shown as the association between health behavior and the use of a wellness program. If you use a wellness program very often, you're more likely to have a higher level of health behavior. If you never use it, you're likely not a healthy person. So not the best examples, but there are various examples. So basically, it's something you're using. You're training more often for a marathon, and your time will be shorter. You are training for, I don't know, whatever example, you're studying for an exam. The more hours you study, the better your score will be. So everything that associates can be quantified in a correlational study. And we will learn the tools in this class, how to quantify that and how to ascertain that there's an association. And in this context, it's important to keep in mind that the correlation is not equal to causation. So correlation means that there's an association which needs to be corroborated and ascertained in random experiments. The reason why that is confounding, because if you have if you are trying to find out whether the participation in a wellness program causes better health behavior, you have two ways to do that. Either you ask your employees, say, do you want to be part of this wellness program? And they're going to say, yes, please. Or others say, no, for sure not. The problem is that self-selection will basically associate with the health behavior before they even became part of the study. So those that have a higher level of health behavior will more likely volunteer to become part of this wellness program. So self-selection is like one of the worst ways to assign people in the group. So because this health behavior at baseline, before the study started, will basically be your confounder. And their health behavior per se will affect everything you're going to see. So you will see, you will have confounded results that you can't utilize and you can't use to in any way extrapolate to a greater population. For this very reason, you basically do random assignment. Random assignment means you're flipping a coin, not really, but it means that they're randomly assigned to either group, either they're part of the wellness program or they're not. By that, you create, in epidemiological terms, it's called equipoise. You have an identical distribution in both groups. So the fraction of patients that have so the health behavior is the same in both groups, and they're randomly assigned. And then you see the health behavior after a certain period in that study. You have really the possibility to compare that and get insights into the effects without confounding. So that's why only randomized experiments can be used to make causal statements. Bluntly spoken, not even those. Not even randomized controlled trials are in any way safe to make a causal statement. It's just, you need to always replicate studies. You need to replicate them in different population, different analytical tools. So it's an insight, and randomized controlled trials are essentially meant to be the highest level of evidence. Second highest level, because there's a even higher one that we're discussing at chapter 8. And in essence, it is a possibility to make a causal statement because you're controlling the confounding variables between the groups. Good. In the same context, it's important to keep in mind that there are two different designs. A between group design is where you randomize people into two different groups and you compare them against each other. If you find differences, if they were randomized, you have eliminated the effect of confounding and you can make causal statements. Keep that in mind. Is a between group design. There is a second form of design, which is a within group design. Within group designs are designs like correlational studies that you can do within a group. With regression, you can also do between groups design, but that's irrelevant for now. within groups design can be correlational studies, or it can be crossover studies. Patient enters the study, is not in a wellness program, then he becomes part of a wellness program and his health behavior changes, and you're sensing that step change in health behavior. It's another within groups design. Analytically, even more challenging than that, than the between groups, but that's different story. Okay, and this is essentially between groups design and within groups design. We talked about randomization. We talked about random assignment, and yep, equal chance of being assigned to any of the groups. So it's really, it should be 50-50, 1-to-1. There are different designs where you can also use ratios between your allocations, but all of this is outside of the scope of this class. Okay, any questions? All right, then have a nice evening, have a nice long weekend, and I see you on Wednesday. Thank you.
Thank you.